everybody. I'm going to go ahead and get us started. My name is Jasmine, and I am the AAS Meetings Coordinator. As a reminder, this session is being recorded, and you'll be able to have access to it within 24 hours, as well as for 30 days after the meeting concludes. We do have a hard stop about 12:29 because we do have a webinar right after this one, but we will have times for questions and answers. You'll be able to unmute yourself and as well as ask your questions in the chat box. So with that, our speaker for this evening or morning, wherever you're at, we have Louisa Rebel, hope I said that last name right, from Caltech.
Yes, thank you. So I tried to inoculate myself against internet problems. And so I pre-recorded a video, which is also available on YouTube. So I'm going to play this now, but I've just pasted the YouTube link in the chat so you can watch it later with closed captioning, speed me up, slow me down, whatever you need. I'll take live questions after this.
Welcome to IRSA. This video will go through an overview of some of IRSA's tools with a similar look and feel. From the main IRSA page, if you click on IRSA Viewer, it will take you into a tool that has the same look and feel as many different tools at IRSA. IRSA Viewer is the most generic version of this tool, so in that sense, it's a good place to start. The first thing you need to tell it is whether you want a FITS image, whether you want to create a 3-color composite image, or whether you want a HIPS image. HIPS images are good for large chunks of sky. If you're looking for smaller chunks of sky, FITS images are probably better. The next thing you need to tell it is whether you want to search in IRSA's holdings, load an image from your disk, load an image from the web, or load an image from the IRSA workspace, which is a tiny bit of disk space you can have here at IRSA. Then you need to put in your target. I'm going to put in M16. Note that it's changed the name into coordinates and echoed below the box what it thinks you said so that you can check that it's right. You can use Simbad or Ned first to try to resolve the name. Then you put the size of the image here. Down here, you have a truly dizzying array of choices of places to look for images. The filtering on the left-hand side is super helpful for weeding down this list. So if you're primarily interested, say, in WISE images, you can click on the WISE filter and it will only show you the programs available in IRSA Viewer that have WISE images. So I'm going to ask for WISE, all WISE data. Now, if I go back over to Spitzer, there's still a lot of programs that have Spitzer. But I know that M16 is in the galactic plane. So if I tell it I would really like just the galactic programs, I then have many fewer programs I need to weed through. I'm going to click on Glimpse because Glimpse did a survey of the galactic plane and is going to provide images for us of M16. Then let's go back and filter just on 2MASS. 2MASS has more deliveries than you might expect. For most purposes, I recommend you pick the 2MASS 6-degree mosaics because they cover larger sections of sky than the original 2MASS tiles. Search. So now it's come back with all of the images it can find from all of these different surveys. Now you can notice right off the bat that not all of them are oriented the same way. I'm going to pick one image, see how it's outlined in orange, that's the current image. I'm going to choose North Up, and then I'm going to choose Lock by WCS. That's going to orient all of the images that I have loaded to the same orientation as the image that I've selected. Now you can see Glimpse is working in galactic coordinates, whereas WISE and 2MASS are working in RA and DEC. The whole row of tools in the toolbox are all things that you can do to these FITS images. If you want to change the color table or you want to change the color stretch, you can do that. Because I have the images locked together for color changes and overlays, what I do to one image is echoed to all of them. Of course, you can zoom in or zoom out. There's a variety of different choices. You can also measure distances on the image. Let's go back to the defaults. And then to measure distances, click on the ruler and then click and drag in the image. If you want to change the units that it's using for that ruler, if you go up to the layers icon, it will give you a list of all the layers it has loaded on the image. So here it's got the target that we searched for and the distance that I just measured. Let's change the units to arc minutes or degrees. If you don't like the color, you can change the color. You can also overlay regions files or add a coordinate system. To turn those things off, click on the icon again. Let's pick a line North Up again to make sure everything is North Up. This icon here gives you a list of the images it has loaded, but this list is stored in something called a Firefly table or an IRSA table. This is an interactive table that's intrinsic to Firefly, the software that's running this tool. So if you want to sort these images by wavelength, click on wavelength, and it's sorted the table by wavelength. Then it's also sorted the images by wavelength. Now you can look at the same patch of sky in all of these wavelengths, sorted from short to long. You can also search for catalogs. Let's go search on the WISE All WISE catalog for this region. You can choose to search a variety of catalogs here at IRSA. You can load a catalog from DISC, you can load a catalog from the VO, or you can load a catalog from NED. I'm going to do WISE All WISE. It's got the same position that I asked for in the images, but now I want, instead of cone, to tell it polygon. Now I can ask it to search over the whole image that I have loaded, or just the portion that's currently visible in IRSA Viewer, or I can change the corners of the polygon that I've asked for. Let's go and search. Now it's loaded the catalog down here, it's overlaid the catalog and the images here, and it's made a plot of the catalog here. Let's change the images to view one at a time, and let's zoom in a little bit. All of these window panes are interlinked, the image, the catalog, and the plot. So if I click on a source in the image, it jumps to that in the catalog and in the plot. The plot that comes up here by default is RA and DEC. So let's change what's plotted. If we go to the gears, we can change it to make a color diagram. So I can do W1 M Pro minus W2 M Pro. That's WISE 1 profile fitted magnitude minus WISE 2 profile fitted magnitude. And then for the y-axis, I can do W3 M Pro minus W4 M Pro. Apply. So now I have a color diagram. If you want, you can add errors. You can even calculate them in quadrature. You can change the aspect ratio of the plot or the limits for the plot. But because these things are interactive, if you want to know which source this one is that's so red in both of these colors, it's this one in the table, and it's highlighted in the plot, but it may be hard to see. Let's change the color of the overlays, changing it from red to yellow. And then there's the source that is red in both colors. You can also filter things. So let's add some filters in the catalog and then ask it for only the high signal to noise sources. Signal to noise ratio greater than 10, greater than 10, greater than 10, and greater than 10. Now we have many fewer sources left in the catalog, in the plot, and on the image, but they're the highest quality detections. Now, as I scroll through the list and select different sources to be highlighted in the image jumps. It automatically scrolls to center the object that I'm clicking on if the object wasn't viewable before. This can be a little disconcerting when you're new at this. If you don't like that feature, you can turn off Pan by Table Row. That's what it's doing. It's panning the image to match the table row that you selected. Let's cancel the filters and let's make a histogram of W1 M Pro. There's a histogram of the WISE 1 values in the catalog. If you have enough sources in your catalog, it will come up by default with a heat map where it has shades of gray corresponding to where sources fall most densely in the plot that you've made. To save the table or the images, you can click on the diskette icon and it will save the image or the table or the plot wherever your browser is configured to save files. Another feature of IRSA Viewer is the time series tool. You can access the time series tool directly from some of the time series catalogs we have here at IRSA. This particular object is in the WISE survey. So if I click on time series tool, it loads the light curves and then I can launch the time series tool. You can also upload a time series from any other mission, but for NeoWise, ZTF, and PTF, it will pull the individual exposures from that survey for you so that you can investigate the individual epochs in your light curve. You can see that there's a big gap in time for this light curve, but you can still look for periodicities. Click on Period Finder, and then Calculate Periodogram, and then calculate. The defaults actually work pretty well for most cases. Here's the peak, and there's the phased light curve. If you want to explore whether or not other peaks provide a better phased light curve, you can do that. You can also set boundaries and have a slider that allows you to slightly change the period and phase the light curve accordingly. So if I accept that period as the best one, we go back, and there's the phase folded data, again, where it's pulled the exposures around the point that I've selected. One of our newest archives is the SOFIA Archive. Click on the SOFIA Archive link. Then I'm dropped into the SOFIA Archive. You can see that it looks kind of similar to IRSA Viewer. Similarly, you put in a target and it resolves the name. You put in the search radius that you want, and then you can put in additional constraints on proposal or observation or instrument or data product, where level 0 and level 1 are the lowest level data, the closest to raw that's available, and level 3 or level 4 is the highest level data processing that's available. I'm just going to leave it on the defaults and click search. On the left-hand side, it's given a list of all of the observations that it found in M42. On the right, there's details about the specific observation. So the first one that it found was a FIFI-LS observation, and there's details about the observation. Let's go to the Forecast tab. Now we've got the individual observations here. If we look at the Coverage tab, all of the polygons that it's loaded here onto this HIPS image are the individual footprints of the individual observations that it found. It's put all of the instruments on here, so you can see that M42 is popular. Since we've got an observation selected in the Forecast tab, if we go to the Data tab, then it will give us an interface, just like we've been playing with in IRSA Viewer, to the FITS image that's part of that data product. Let's go to one of the spectroscopy instruments. If we go to Exes and then find that product, it will show us the extracted spectrum from that data product. You can interact with it in a plot, or you can interact with it in table format, where just like the other tables like this, you can impose filters or sort. And in the chart, you can select a region, filter down, and then it zooms in on that section of the spectrum. Each instrument has different data products. So you might find some data products that are not shown because they're relatively low level data products. Sometimes you can find higher level data products that have multiple planes that then you have to scroll through to figure out exactly what data are there. For GREAT, here's an example of proprietary data. The rows that are red are still proprietary, so unless you have access to those data, you can't even see a preview. But the observation that's selected is public, and so you can see there's a representation of the spectrum that it has. For some of the GREAT data and some of the Hawk Plus data, the preview tab is populated so that you can see what the data products look like if they're combined. There's one. There's an example of a combined data product that is shown in the preview here. There are lots of resources available. If you go to the IRSA main page and go down here, there's lots of video tutorials that are available. Most of them are much shorter than this. We've got this, the page that's here is designed to sort of give you an orientation to the diversity of videos that we have. I'm using the playlists as a sort of table of contents. So if you want to see all of the videos associated with Find Your Chart, you can go to that playlist. The IRSA Help Desk is also available at the bottom of the main page if you need help.
So I've been trying to watch all the various channels, communication channels for questions. I know that the SOFIA Archive yesterday was talking about how to search individual programs. So if I stop sharing that window and share, let's see, where did it go? This window. We can go to the SOFIA Archive here. And yesterday in their webinar, they were talking about searching for the Galactic Center data. So if we go to the proposal constraints and put in the plan ID they mentioned in their webinar, and then search, you have to tell it, I want all the data from that program, not just search by position. And then it will come back with, hopefully my internet has not gone down. There's all the Galactic Center data, and it will show you an overview of the coverage map associated with this data. which looks an awful lot like the stuff they were showing in the webinar yesterday. Are there more questions? I'm trying to monitor the chat window, looking for questions.
So far, I do not see any questions.
Okay, let me see what other tricks I can show you. So if you go to the catalog search, we do not have Gaia DR3 in here yet, hopefully in the next several weeks, but we do have Gaia DR2. So we can put in, let me show you the multi-object search. So for this, you can, for example, I have the Gliese-Gerais catalog of nearby stars in here, if I can find it. There we go. So what it's going to do is I have a list of all of the GJ stars in this table, and I'm going to explicitly tell it I want one-to-one matching, meaning that give me the closest object to each one of these positions within 2 arc seconds. If there are more than one source within 2 arc seconds, give me only the closest one. So I'm going to tell it to run query, and because the GJ catalog is very large, this may take several seconds, but that's okay because I'm trying to fill another 15 minutes. What I'm going to do is when it's going to come back, it's going to have the same kind of interface that I've been showing, where there's a plot with the objects overplotted on the sky, a plot of the catalog that was returned, and the catalog that's below. Hopefully it will not take too much longer.
And Louisa, we do have a question in the chat box.
Excellent.
After
Is there a list of those archives that contain time series data? So the WISE data are, both WISE and NeoWISE. PTF and ZTF have time series data, and then there are deliveries that people have made back to IRSA that have time series data. So right now, there's not a ton of time series data in IRSA. But I use the time series tool all the time. So if I go, let me let this one continue to run. Let me get the time series tool up here. For my science, I study rotation of young stars. So I have hundreds of light curves that are from K2 or from TESS. So instead of picking WISE, I'm going to pick other. And then the light curve that it pulls up. So there's the light curve that I have that's come from K2 processing. As you can see, it's got a lot of outliers. So I can click and drag to filter down and get rid of the outliers. Then I can send it to the period finder. And it's got a lot of points, so it's going to take a second. This one is still working. So it's going to, just like before, it's going to give me a periodogram down here and a list of a table of the periodogram here. And I can interactively pick the peak and have it phase the light curve. Okay, so there's the peak. There's the light curve. So this star is rotating in 14.5 days. And this one in particular, you can choose different periods from different peaks and see if you like the phase light curve. In this case, 14.675 is clearly the right period. Then I can accept that period and go back to the input view here. So this Gliese search is taking longer than I expected. Okay, there we go. So what we're going to do here, you can see there's Gliese sources all over the sky, right? So this is the one-to-one match that I asked it for. And sometimes it didn't find a match. Maybe 2 arc seconds wasn't the right radius to use. But let me change what's plotted. Let me put for the x-axis, I happen to know that this catalog already has, oh, that one's coming back. Come on. So I happen to know that this catalog already has calculated the colors for me. So if I go down far enough, here we go, BP minus RP. So I can use that for the x-axis, and then for the y-axis, I can't make this window bigger. So what it's doing, it's taking the observed G magnitude and then correcting for the distance. But of course, distance isn't tabulated, parallax is. So then I can apply, and whoops, we need to flip that y-axis so that bright objects are at the top. So let's reverse the y-axis. And so there's a HR diagram. Let's select just the white dwarfs. And those are just the white dwarfs that are in the Gleasy catalog. From Slack, does IRSA have an Ask to Query like API in Python? Yes, there's another Python tutorial later today, which will be covering some of that. More questions coming in from any of the myriad vectors.
So far, it looks like that was the last one.
Okay. Let me see. So if you want more information on interacting with the VO, there's documentation, you know, how to interact with the IRSA archives through the API. Here's the Astra Query information for how to access IRSA via Astra Query. IRTF is one of the other relatively new archives. You can, this one is a lot, it's all spectroscopy that we have. So if we search in here, it's pretty straightforward, just like the other ones. You search by position and it gives you what it found. And then to download the data, select the row that you want and then download. Let's see, what else can I show you? Find your chart gives you the same chunk of sky in several different bands. So DSS is the PAS Observatory, the Palomar Observatory Sky Survey, Sloan SDSS, TUMAS, WISE, Spitzer, Akari, and IRAS. And you can also search the catalog at the same time. I'm going to turn that off for the moment. There's the same patch of sky for M101 from all of these surveys. If I'd like to add a color image at the end, I can click on that icon. We'll add a color image at the end of each row using data from that row. So in the chat window, there's this. Most of IRSA's holdings are available through VO compliant APIs. So there's the Python package that uses the VO protocols to talk not just to IRSA, but all of the archives that have a VO interface. Okay. There was a webinar on Monday on Spitzer. Yes, so in the chat window, let me just echo this. At every AAS, the NASA archives get together to do a workshop about how to access NASA data through Python. That was last Thursday, but there's the materials from that worksheet. Does anybody know if that workshop was recorded and if it's recorded, if it's posted on the meeting site?
It was recorded. Yeah. I don't know where it's posted right now.
Okay.
It's under our VFairs platform. I'll put the link in the chat. Give me 1 second.
Yeah. Yeah. Okay, so there was a webinar on Monday that was talking about how to access the Spitzer data. And so this is how, there was a question there about how do I find globular clusters? So you can search on strings and it will give you the list of all the programs with Spitzer that observed globular clusters. Of course, it's just searching on a string, right? So you go down far enough and you got high redshift clusters, but near the top, there's globular clusters. There was also a question in the Slack channel during that about how to find spectroscopy. So the IRS enhanced products are reduced data that are already available. So you can search you can search through the IRS enhanced products, but you can also, if you just search, on a target, you can ask it, tell me what you've got that's Spitzer related covering that position. And it will give you, in the chat, yes, there's a play button next to it. Yes, so within VFairs, I'll do that too. Just a second. So there's the all of the observations, but if you want to see the reduced spectra that are available, you go to the IRS enhanced tab, and there's the reduced spectrum that it found. Okay, So let me, just because I keep seeing this question so many times, I've even made a movie for this. You can watch in Slack. I've been posting it. You go to the VFairs, log in, make sure you log in as an attendee, not an exhibitor. And then you want to go to the auditorium and then click here to join sessions. And then you go find the webinars that you care about. And it's trying to give you the things that are happening now. And you know about that join button, and the future ones are, you know, there's nothing there yet but a countdown. You go down to the older ones and there's a play button, and that play button is what gives you the recording, but you have to give them a chance to turn the videos around, right? It's not instantaneous, it's not automatic. So there is a recording, and the recording will eventually show up with a play button, but it may not be instantaneous. Okay, more questions? Back 5 minutes early.
All right. Yeah, so if there's no more questions, we can end and get 5 minutes back. But let me double check the Slack channel as well. Looks like we're clear. And no more questions in chat. All righty. So I want to thank everyone for attending this webinar, and thank you, Louisa, for all your help and
No
a great,
problem.
great presentation. And please go to, oh, go ahead.
I was just going to say, well, we'll be in the booth later. So please, please, please come by the booth. Ask us questions. We can give you an additional demo, whatever you need.
Thank you.
Okay.
And yes, the Python workshop. Yeah, I'll just read in the chat. Yep. All righty, everyone, have a good rest of your evening.
Thank you. Bye.